All right, hi everyone. Happy Halloween. Happy November. I thought I would just do a quick video showing my process. Hopefully this will help you guys understand why things are going a little bit slowly right now. Okay, so right here, now I'm on my main branch of Mavis Inference, and I'm kind of just going through and looking for opcodes in the Erlang virtual machine that show up in the modules that I haven't implemented yet. So right now this is a little bit slow because I don't have any caching, and I'll probably turn that on once I've cleared as many of these as I can. And you can see that I also haven't implemented a bunch of tests for some of the opcodes that I have written. They're just mostly there as reminders for myself to actually do it. Now, the reason why this is really slow is it's going through all of the modules it created, and most of them call into the Erlang module. And Erlang module is quite big, and at the moment, like I said, I don't have any caching of information. So it's actually recursively trying to infer the Erlang module over and over and over and over again. So hopefully that'll get fixed and things will go a little bit faster pretty soon. Okay, so what I'm expecting to see is at some point it's gonna give up the ghost on one of the attempts to infer the types for something, and then it'll start spitting out a bunch of errors. Here we go. Okay, these are still test errors, but if we kind of scroll up, we can see, oh, those are timeout errors. Here we go. So this is the sort of error that I'm looking for. It says, I don't know what this opcode is, allocate 063, and here's the context in which it appears. And so this is kind of like a block of machine language code that shows up. I don't want to work on allocate 0 right now. Oh, this one's interesting. It's a move. I actually have move programmed, but I don't have it programmed for Y registers, only for X registers. Let's see. Here's another move with Y register, another move with Y register, another allocate 0. Okay, here's a good one. Is non-empty list. I might actually go ahead and implement that. Let's keep going though. Maybe there's another one. Loop rec. I have no idea what that is. Case end. Try case. Move. Another move with Y's. Is exact. All right. Let's do is non-empty list. So let's go ahead and copy that. And all of my tests, so this is, note that this opcode starts with the atom test. So that goes in this module opcodes.tests, which is where I stash all the opcode code for tests. So currently I only have is nil and is exact. And I've written kind of like a little bit of a DSL for this. So you declare what the opcode is, and then you declare what the processing for it in the forward direction is, and you declare the processing in the backward direction. This is a little bit of a lie. These are not terminal opcodes, which means it's an opcode that shows up at the end of a block of code. But the nice thing is that if you attempt to back propagate through this opcode, it will raise an error, which is why I kind of make that my default way of handling this, to remind myself that, hey, I need to write more of this code. So that's what that looked like. And then let's go ahead and just copy this one. And I'm just gonna go ahead and comment this out. All right, is non-empty list. Copy. And that's the fail condition, and that's the from condition. Okay. All right. So basically, the way this opcode works is, if the contents of this register is a non-empty list. It keeps going and continues with the next operation on the code list. And if it doesn't, it jumps to the label that's marked by this F atom, and then executes the code there. This is a lot like JMP commands, or JNE, JE, those sorts of commands if you're used to x86 assembly. But, this is the Erlang virtual machine assembly code, so, it's necessarily different. Okay, so once I've kind of got that thing in there, the first thing I do is, well, actually, you know what, maybe I should just comment out even these. And so we just want to recapitulate that error. So I have tests on opcode tests. And so let's copy, all right, code for the is-nil opcode. And then some of these we're not going to write yet. And then what was the opcode that we're going to test? We're going to test is non-empty list. Okay, is non-empty list opcode. Okay, and let's change the names of these. So what these tests is going to do is it's going to set up kind of a fake code block. And the fake code block is going to contain this opcode, which tests for the non-empty list. And also it's going to after that, add this opset 0. And what opset 0 does is defined here. It just moves the atom foo into the 0 register. One more important thing that's going to happen is that I'm going to precede the test thread with a message that contains the information for block number 10. So this is typing information for block number 10, and it says that block 10 needs this to be an integer and this to be a float. We may wind up changing that in a second, but let's go ahead and play around with this for a moment. Okay, so 10, let's be an integer. We're gonna check register 1, I'm guessing. Okay, so the fail needs to be 10 because that's the block that is gonna contain the other fail information, and this we're gonna make 0. So we're gonna check if the contents of 0 is a non-empty list, and otherwise just go ahead and move on. Okay, so forwards propagates a type on non-empty list. So let's just go ahead and run the test right now. So Control-Shift-T. Oops. New terminal. And actually, let's only test this thing. And we can see that block not captured. Forward propagates the type that matches the jump condition. That's not what we're looking for. We're looking for is non-empty list opcode. Forward propagates when on non-empty list. So this is the one we want. Okay, unknown opcode test is non-empty list. That's exactly what we expect. So let's just go ahead and laser focus our test on this case. Oops. Test. Great. Okay, so first we need to get this unknown opcode to clear. So the way to do that is to define the opcode. So I'm just going to go ahead and uncomment these. And let's just go ahead and raise. Okay, great. And now our runtime error is reached. So we know that we're making it into this point. The way this opcode works is it generates a function that matches on test is non-empty list f fail x from. And then now I declare this forward block, which does the processing, and the state contains the register the current register information for what things look like when you're at that point. Okay, so what we need to do is going back to this tests. We need to make it. So let's preload this with the type that we're looking for. So type dot list. Let's just say type built-in any, and then non-empty true. So if if a register 0 contains that type, then what's going to happen is we're going to do fast forward, which means go through all of the operations in the code list. And so it's going to pass this test, and it's going to move on to the next one, which is going to set the value of 0 to foo, which has the type foo. So here's what we expect. I'm going to go ahead and make this non-empty list. Basic non-empty. Oh, we'll call this non-empty any. So we're going to preload into the 0 register non-empty any, and then what we're going to expect is that at the beginning of the code history, it's going to have a non-empty any, and then at the end it's going to have foo. So let's run this again. We're still going to have a problem. Oh, did the test 79. And okay, so it still reaches this runtime error, but let's look at the state. So state, and state has a parameter called x, which is the x registers. So I'm going to inspect that, and you can see that inside that we have non-empty list. Excellent. All right, so let's go ahead and keep going. So I'm gonna drop this in a cond, and you know this may wind up changing. This sort of implementation may wind up changing for now, but let's just write the test. State and so this is the 0 register has the non-empty list, right? So I have a function get register state 0 equals. Actually, let's match on it. Okay, so if that matches, then what we're going to do is we're going to say, okay, we match, and just keep going. And so the way we say keep going is return the state. And then let's do true raise unhandled case. Okay, so let's test this. And it passes. Excellent. All right, so let's look at the next one. Forward propagates the type that matches the jump condition, which is going to be, let's just preload something that isn't isn't a non-empty list. In this case, it actually has to be built-in integer because the previous one, the previous thing demands that it's a that it's a built-in integer. Okay, so let's see what happens if we run 88. And so note that the function that we're injecting requires that the 0 register is preloaded with an integer, and then it makes a built-in float and drops that into the 0 register. Again, also this kind of syntax may wind up changing in the future. So we start with an integer, we return a float. So what our expectation is that after we so we'll start with 0 with a built-in integer in the history of this code run, and then at the end it's going to have a built-in float in the 0 register because it did not pass the condition. Let's go ahead and also inspect that. Oops, we want 88. Okay, so unhandled case. That's exactly what we expected. It didn't quite make it through there. And so what we want to do is we want to make OK and then grab the required values from the fail condition. So let's see. So this will wait for the block that contains the fail block to finish, and then figure out exactly what it will figure out exactly what those types are. Now, I will show you one thing. Because the results of the jump block can have multiple different possibilities, starting with one type and returning a different type. This will actually be a list. Okay, so let's just do this. Not a result. So first of all, we got this invalid forward result, but note that it's in a list. So for now, I'm just going to destructure this into a single possibility. I think in the future, we'll have to write code that handles the case when you return a block that has multiple sort of possibilities. But for now, I'm just going to keep things simple. And we're going to call that result, jump result. And see, here we've got this makes a float and requires an integer there. So for now, we're just going to jump here. We're not going to do any sort of checking on sort of the needs. That will come later. But yeah, so let's do this. So okay, we're going to put register state 0 jump result dot needs or makes, and so that should make this pass. Oh, right. It's expecting built-in float. Why did that not show up? Hold on, 36 makes a float. Put register 0. Let's see. So the history says register 0 float, register 0 float. Oh, and it became foo again. Ah, right. Because we need to so what's happening is I'm putting this float value in there, and then in the next in the next opcode, it gets overwritten. Now, in order for it to not be overwritten, I need to tell the code processor that in this branch of the history, we already kind of jumped away and did something else, right? We jumped to a different code block or a different label. And the way I do that is I have a keyword called freeze, and that tells it to not do any sort of alterations as it passes through other opcodes. So now we should get built-in float. And you can see the history of this is we started as an integer, then we went through the first opcode, which is the testing to see if it's a non-empty list, in which case we got this, right? And then when we went through the move operation, which is take the atom foo and drop it in register 0, we didn't do anything because it had already been frozen. And so that's why you can see this reg frozen, which indicates that this set of registers has been frozen. Great. So that passes. I'm just going to do one more, which kind of shows you the sort of different ways that this system works. This is nowhere near a complete implementation of this particular opcode, which is to check for non-empty list. There's going to be a lot of things that I've got to test. But let's just go ahead and do the case where I don't drop anything in the test register, right? And so what we're going to expect is maybe two different possibilities. One where we have a non-empty list of any, right? So type dot list, and it should have non-empty true, and the type of the list should be built in. So we're going to make that the first history. The other history is going to require built-in integer because that's what the jump condition requires. And then in this case, we do want these to be the same because the history 0 or history number 0 is the history where we did give it what it wants, and so it should then go ahead and write foo into register 0. And then in the case where we dropped in an integer, which is not a non-empty list, it will jump, and then we should get a built-in float in at the end. All right, so let's go ahead and run this test. It will fail, I think. Oops, wrong number, 105. Great, and so what failed? In this case, we did not write. So what happened is we didn't pass in any initial registers, right? So at the start of this history, there is nothing instead of an assignment of this type. All right, so how do we deal with that situation? I'm going to write a condition that in the case where state is map key, so if it doesn't have a key for the zeroth it doesn't have a key for the 0th opcode, right? So state.x. Actually, we care about the from. Then what we need to do is we need to backpropagate. And we're gotta do put register from state from, and then we're gonna drop the non-empty list in there. So type list type built-in any non-empty true. And so that'll force a condition where like one of the ways to get to this function to be a non-empty list. And so when we go back and do the type analysis, we can see that the acceptable initial parameters for this function is the non-empty list there. I do think that also maybe we want to drop in the possibility that there's an integer in that slot, but I'll go ahead and I'll take care of that one later. Actually, you know what? This type doesn't demand it to specifically be a non-empty list. It could be anything. So really, this should be built-in any. Like, is non-empty list won't fail if you pass it something that's weird. So this should be built-in any, and then we're going to go ahead and make this built-in any. Great. So that allows us to fill this, pass anything to this function, and it should be fine. Okay. There is no list last. Back power put state from built-in any. Okay, let's make sure that that's reasonable. And we did get there. Let's take a look. Oh, Oh, okay. Oh, I see what the problem is. The problem is that there's only one possible future here, so we can delete these test cases. That is what. And so we got float here. All right. So that's kind of, oops, built-in float. So I don't know if like this really was particularly helpful, but you can see sort of all of the steps that I need to go through to make sure that, you know, the system that I'm building actually makes sense in the scheme of being able to like go through and properly process opcodes and figure out what the tests are. You know, a lot of this stuff is still in flux. All these nice macros and this DSL that you see that I'm using to build opcodes, it's still in the kind of clunky state that I don't particularly love it all that much. And so I'm still kind of like searching for ways to make this make more sense, if you will. But you know, it's slow going. I gotta basically write logic for each of these opcodes to tell you exactly what the what to do. And so, you know, sit tight. You know, I complete maybe about 2 or 3 opcodes a day at this rate. I think there's something like 150 opcodes in the Erlang virtual machine. But hopefully after I kind of clear an initial set of sensible opcodes, I'll have really sort of fleshed out this DSL in such a way that like writing logic for more opcodes is not completely painful. So, you know, like I said, just a sample for the process that I'm going through right now so that you can understand why things are going a little bit slowly. See you guys soon.